Hello friends, we are going to take a problem for finite slope. So in this problem, we will have to check for the stability of the finite slope. So check for the stability of a finite slope by phi u equal to 0 analysis. So Swedish slip circle method, we all know it, that if we have, and the informations for all the data are given to you. The height of the slope, finite slope, is 10 meter, and the slope angle beta is 45 degree, and therefore the Frobenius angle, directional angles alpha 1 and alpha 2, you can find out from the table given by Frobenius. So directional angles can be found out very easily, that is 28 degree and 37 degree. So Frobenius directional angles are also known to you, and you have to check for the stability of a finite slope by phi u equal to 0 analysis, and the failure is 2 failure. So how will you proceed? What we can do? The height is given, and the slope angle is 45 degree. Naturally, we can take on a paper a point, and as you know, the height is 10 meter. So to certain suitable scale, this height of 10 meter you can plot on a piece of paper. So take some suitable scale and the height of 10 meter, to that scale you can plot it. Now the slope angle is 45 degree. So if you go by the same distance and join these 2 points, this angle is going to be 45 degree. So this angle will be 45 degree. So this is the slope. You can plot it. Now the directional angles alpha 1 and alpha 2. So if I call this point as A, this point as point B, then with respect to AB, the directional angles is 28 degree. So at 28 degree, draw a line, and At B, alpha 2 is given to you as 37 degree. So this angle is alpha 2 equal to 37 degree. So wherever it intersect, you are going to get this point which is taken as O. Now OA as the radius, you can have a circle because it is a two failure. So from here, taking O as the center, OA as the radius, this becomes the slip circle. So it is going to be a two failure. And this is the slip circle. Now, having got the slip circle, join this point. From here up to here, AB, let's call this point as D, and measure this angle. This angle is called the central angle delta. So, how on a piece of paper, graphically, we can solve this problem. So, what we are going to get from the plot, we get delta, and we can measure it. So, measure it, it is 90 degree. When you plot it, you will be getting it as 90 degrees. So, delta you know it, and radius also you can measure it. So, radius equal to 15 meter. So, to whatever scale you have chosen, you are in a position to take it. So, in phi u equal to 0 analysis, you need to find out the weight. So, for weight, you require the value of gamma, and gamma is given in the problem. So, Cu is for this, it is given that Cu equal to 20 kilopascal. So, given that Cu, the undrained cohesion is 20 kilopascal, and phi u equal to 0, and gamma equal to 20 kilonewton per cubic meter. So, these are the given data, and you have been able to plot it. Join A to D. And measure AD also. So, AD is going to be equal to 21.15 meter. So, this becomes 21.15 meter. To suitable scale, you just do it. Now, what you can do is you need to find out the weight of this section A, B, D, A, and from O, let's say you have been able to find out the weight which will be acting at the center of gravity. So, this is the weight, total weight that you need to calculate. So to calculate the weight W of the section A, B, D, A, gamma is already known to us. If we can find out the volume, so first let us calculate the area. There is the sector O, A, O, D, A, this complete sector. It is a part of a circle. So if you want to find out this, the area of this part, because you need the weight. So what we want is the area. So to calculate the weight of the section ABDA, we need to find out the area of ABDA. This will be equal to area of AOD, AOD is a part of a circle, AOD. Now, from this, you can take out this triangle AOD minus triangle OAD. OAD. So this triangle is completely taken out. Then you add this triangle ABD plus triangle ABD. So from this complete sector AOD, complete AOD, you can minus triangle this is the circular part, minus triangle plus triangle. That will give you this area which is hashed. So area of ABDA will be this area, let's say it is A, area of AOD. Now what is the AOD? It is a part of a circle. So it is very simple now. We know how to find out the area. If it is complete circle, it is pi r square, but it is part of a circle. So 360 multiplied by the central angle, which is 90 So into 90 So this area of minus triangle OAD. Now from O on AD, you drop a vertical and measure it. So O to D, what you can do is going to be 90 So O, A, B, C, D, let's say this is E point, and for this triangle from B, you make it right. Let's say this point is E from the vertex, B, E, and this point is F. So you are going to have E and F. This becomes F. So just O to this. So this larger triangle OAD, triangle OAD will be half into base. Now base is 21.15. Now because you have dropped a vertical OF, so measure OF, and if you measure OF, you can record it, and this OF is 10.5 meter. So after measuring plus this quantity, the last one, the triangle ABD will be half into base is 21.15 multiplied by B2E. So measure B also, and B is 4.08. So you will have to just drop a vertical 90-degree on AD from point B and from point O, and therefore you get the area which is required. So if you calculate now, having everything, take your calculator and let us calculate. R is already known to you as 15 meter. So the calci, if I take it, so now pi r square (21.15 into 10.5 plus 0.5 into 21.15 into 4.08. This gives you the area A. So the area of ABDA, this section, is 108.82 square meter. Now having got the area and having got the value of gamma, we can find out the weight. So weight W, which is required of ABDA section, will be 108.82 multiplied by 1 perpendicular to the board. This becomes the volume multiplied by 20 kilonewton per meter. So 108.82 into 20, the weight is 2176. So this becomes 2176.46 kilonewton per meter length. So friends, the weight is known to us. So in phi u equal to 0 analysis, how to check the factor of safety? Now the things becomes quite simple. We know how to find out the factor of safety. Now what you can do it, once you know the line of action CG of this area, you can find it out easily and find out the value of x bar. So let's say the x bar is known. The line of action, you can extend it in the backward direction. And from O up to this is going to be x bar. Measure it. If you measure it, x bar, you will be getting as 5.56 meter. So friends, the line of action from O is at a distance, horizontal distance of 5.56 meter. So see how simple you can solve this on a piece of paper. Now, having got all the informations, now let us find out the factor of safety. So to find out the factor of safety, the factor of safety for a finite slope by phi equal to 0 analysis is given by Cu, which is given over here as 20 kilopascal. So Cu into length of the arc, that is AD. What is the length of this arc? Multiplied by the radial distance divided by W into x bar. In the denominator, you know everything. Now here it will be Cu and the length of the arc will be R into theta, R into delta. So R into delta should be in radian. So you will have to multiply it 180 degree equal to pi radian. So delta degree will be pi by 180. So R into delta, delta in radian, by multiplying by pi by 180, you can convert it into radian. So L arc is known and R is already known to you, divided by W x bar. So what you are going to get it is Cu into R square multiplied by delta, that is 90 divided by 180. So it is going to be 0.5 into pi. So 90 divided by 180. So pi by 2 divided by W we have already calculated as 2176.46 and x bar we have measured as 5.56 meter. So friends, now you will be getting the answer 20 R square into 0.5 into pi divided by 2176.46 into 5.56. 6. So what is this is called the factor of safety. And you know that factor of safety must be greater than 1.2 at least. So in the denominator, if you multiply this weight by 5.56, I am getting 12,101. So this becomes 12,101.12. Okay, this whole multiplication, and in the numerator you have got a 20 into 15 squared multiplied by pi this is 0.584. Therefore, the final calculation of factor of safety is coming out to be 0.584. Therefore, slope will fail and slope is not stable. This slope will never be stable, never be stable, because the factor of safety is less than, at least it should be 1.2. This is how the finite slope you can do it. Any problem on finite slope you can do it, whether it is phi u equal to 0 analysis or it is C phi analysis. So everything, if it is C phi analysis, both C and phi value will be given to you, and you will have to divide it into at least 5 slices, and the weight of each slice you will have to find out. The normal component you will have to find out. Tangential component you will have to find out, as explained in the previous video. And then you can find out the factor of safety by C phi method also. So problems are quite simple. You can apply the theory and get the answer. So I hope this is crystal clear to all of you, and I sum up over here. In the next video, I will come up with different cases and some more informations on the stability checks of a finite slope. Thank you very much.